Hey everyone! If you're gearing up for NEET, you're in the right place. Today, I'll break down the basics of rotational motion, a topic that's often considered tricky but is actually quite fascinating. So, let's get rolling. First up, what is rotational motion? Simply put, it's when an object spins around an axis. Imagine a ceiling fan or a merry-go-round. Both show perfect examples of rotational motion. Now, let's get into some essential terms. 1. Think of it as the rotational counterpart to linear displacement. It's usually measured in radians. 1. It's the rate of change of angular displacement and is measured in radians per second. 1. It's the rate at which angular velocity changes with time. Now, let's talk about. This is a crucial concept. It measures how much torque is needed for a desired angular acceleration around an axis. Think of it as rotational mass. The more mass an object has and the further it is from the axis, the higher its moment of inertia. Oh, and here's a tip. For exams like NEET, remember that moment of inertia for simple shapes like rods, spheres, and cylinders often come up in questions. So, don't forget to memorize the formulas for these. Next, let's dive into. Torque is like the rotational equivalent of force. It's what makes an object start rotating, stop rotating, or change its rotational speed. Mathematically, torque is the product of force and the perpendicular distance from the axis of rotation. A common example to understand torque is opening a door. If you push near the hinge, it's tough to open, but push further from the hinge and it opens easily. That's torque in action. Now, let's connect these concepts with. Just like Fsama in linear motion, for rotation, we have torque E1, E1. Here, I is the moment of inertia and R is angular acceleration. This tells us that the torque applied to an object is equal to the product of its moment of inertia and angular acceleration. Lastly, don't forget. This principle states that if no external torque acts on a system, its angular momentum remains constant. You see this in action when figure skaters spin faster by pulling their arms in. Alright, that's a wrap on the basics of rotational motion. Remember, understanding these concepts is crucial for cracking NEET. So, keep practicing and stay curious. If you found this helpful, give it a thumbs up and subscribe for more NEET tips and tricks. Catch you in the next video. NEET Abibi ki ji ikika